Alrighty, this brings us to lesson 13-7 here with Miss Curdy, and what we're going to be talking about are whole numbers as fractions. So we already know that we can have fractions that are less than a whole, greater than a whole, or equal to a whole. But now we're going to be looking at fractions that, here he comes, fractions that are actually equal to several wholes. So every whole number can be represented as many different fractions. So for example, here if I'm looking at 3 wholes, I can represent it as 3 over 1 like this. I can also represent it as 6 halves, 9 thirds, 12 fourths, 15 fifths, and I can literally go on forever and ever and ever. I won't. But you can actually go back and review your topic 12 notes titled Fractions Greater Than 1 and More Fractions Greater Than 1 Whole to kind of review this. So some of you may have started to notice a relationship between fractions and multiplication and division, and they're very closely related. So something interesting is that fractions have like a hidden division equation inside. So let me show you what that looks like. Okay. Carl deciding to. Let's get a look. Hi, bud. Psst, psst. Isn't the camera shy? Hi, buddy. All right, he's gonna lay here while we do fractions. Let's pause. All right, so again, something interesting is that when you look at these fractions with whole numbers, that they seem to have a little bit of a secret division. Now, if you look at the division sign, I always found that's kind of cool, that it almost looks like a fraction if these two dots were actually our fraction numbers. So looking at a fraction like 12 fourths, we can think about it as 12 divided by 4. 12 divided by 4, which would give us 3. And 12 fourths is actually equivalent to 3 wholes. Let's look at another one. Let's look at these guys up here. 15 fifths would equal 15 divided by 5, which equals, again, 3 wholes. 6 divided by 2 is 3, 9 divided by 3 is 3, 12 divided by 4 is 3, 15 divided by 5 is 3. And that's how we know that they are equivalent to 3 wholes, 3 whole things. Again, so we can think about kind of like fact families. So if I were asking you to tell me how many thirds we would have in 5 wholes, you can think, okay, what number divided by 3 would give me 5? And again, thinking about that fact family, I know that 5 divided by 3 would give me, 15 divided by 3 would give me 5. So let's find another equivalent fraction to 5 wholes. What number divided by 4 is going to give me 5? And the answer would be 20. So we'd have 15 thirds here and 20 thirds there. How many eighths would we need to make 5 wholes? And I can think what number divided by 8 would be 5, and that would be 40. So 40 eighths is the exact same amount as 5 wholes. And then 5, how many wholes would that be? 5 divided by 1 would give me 5. So 5 over 1 here. I'm going to have you try a couple on your own. So let's do 3 holes. Let's do 6 holes would equal how many fourths? So take a moment to figure that one out. 6 holes equals how many fourths? And then meet me back here. All right, so again, I'm going to be thinking of fact families. What number divided by 4 is going to give me 6? And my answer to that would be 24. 24 divided by 4 equals 6. Let's try how many thirds would give us 7 wholes. So again, let's pause the video, see if you can figure this one out. What number divided by 3 equals 7? And the answer to that would be 21. Again, knowing your multiplication facts make it really easy to figure out these fact families. 21 divided by 3 equals 7. And keep in mind that this fraction bar is a lot like our division symbol up there. All right, so that's one way to think about our whole numbers. Let's look at another way. So let's look at fractions equivalent to 4 wholes. So up here I've got a picture of 4 wholes. 1, 2, 3, 4. They have not been broken up at all. So I want to know what fraction with a denominator of 3 would equal 4 wholes. And in order to find out, I would break each whole up into thirds, or 3 pieces. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And now I'm going to count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 thirds. And again, using the same trick we did on the other side, 12 divided by 3 indeed equals 4 wholes. All right, let's do one more. I'm going to have you do this one on your own. So what fraction with the denominator of 4 would equal 3 wholes? So in order to find out, draw a picture of 3 wholes, just 3 rectangles, break them up into fourths, and then count them up. So you can go ahead and pause the video, try that one on your own, and then meet me back here. And this is something that definitely requires some time to make that drawing accurate. All right, so let me draw my 3 wholes. I'm just drawing 3 quick rectangles. And then I want to break them up into fourths. Let me switch colors. Half and then half again. Half and then half again. Half and then half again. And now when I count them up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And again, 12 divided by 4 indeed equals 3. So I know that 3 wholes is equivalent to 12 fourths. So that is 2 ways to figure out what our whole numbers would be as fractions. We can think about our fact families, thinking about these fractions as a division equations, or missing division equations. 15 divided by 3 is 5, 20 divided by 4 is 5, 40 divided by 8 is 5, and then 5 divided by 1 is 5. Or we can draw it out in pictures, knowing how many wholes I have and what my denominator would be, and breaking it up into that many pieces, and then counting them up. But again, this is whole numbers as fractions. So go ahead and hop into your workbook for 13-7 and try some of these out. This is another one of those tricky topics, so please meet with your teacher if you would like an additional mini lesson, and I will see you back here for the next topic. I hope you have a really great day. Bye.